That's fine. Do you have it here?
Yeah.
Okay. Are you ready? Okay. Maybe I just write it here. Okay, everybody. Who has made some attempts on some of the problems that I gave you? Okay, great. Which numbers have you been able to do? 4, 5. You are doing 6. Anyone else? Which one? Elsie?
I did
1 to 5. Okay, great. All right. Few things you are missing are the basic terminologies in matrices. So please pay attention just for a few minutes. What are matrices? Are objects like this are matrices. 2, 1, 3, 4, 0, 9. This is the plural. If it is singular, it's a matrix. This is the plural, matrices, just like child and children. Does it make sense? So we use capital letter. Joey, are we getting this?
Yep.
Okay, great. We use capital letter to represent matrices. So I don't want to see anyone writing A equals 1, 2, 3, 4, 5, 6 like that. Please avoid that. Because a lot of people are fond of, it's the same thing. No, it's not. Avoid that. We use block letter, capital letter to represent matrices. If we need to write the elements or the component in it, we use small letters for that. So if I want to describe a matrix, I can write B equals A, B, C, D, something like that. Then this makes sense. Okay? Now, what are matrices? I'll just give a simple definition. Of course, nobody will ask you what is a matrix. It is a rectangular array of numbers. Okay? Of course, we arrange them in rows and columns. And columns. Now, what do we mean by row? Look at this. Tell me which one is row in A.
2, 1, 3.
2, 1, 3. That's row 1. What about the second one will be row 2? So this matrix has how many rows?
2 rows.
2 rows. What about the columns?
2, 4, 1, 0.
So this is 1 column, 1 column, 1 column. So it has 2 rows and 3 columns, right? So we call this a 2 by 3 matrix. Listen again. Some of you are writing whatever I don't know you are writing. Then you're going to come back with the same problem of what does it mean? Again, 2 rows, 3 columns. So we call it a 2 by 3 matrix. We don't call this times. It's pronounced by. So this is what we call the order of the matrix. I'm going to write it there, don't worry. I just need to listen to the explanation. I'll be writing it here. So by order of matrix, we mean the number of rows and the number of columns. So in the first question, I'm telling you to write the order of the matrices, isn't it? So I want you to just simply find out how many rows and how many columns and write it in this form. Do you understand? So, yes sir, quickly.
Does rows always have to go first?
Yes, rows have to go first. Number of row by, that's a very good question. Row first, followed by the columns. Now let's look at 1A. What would be the order in 1A? 2 by 4. So all you have to do is write it in this form, 2 times 4. But it's not 2 times 4, it's 2 by 4. That's how we pronounce it. What about 1B?
1 by 3.
1 by 3, correct. What about 1C? 2 by 4 also. So that's what we mean by order of matrix. Yes, sir.
Wait, 3 by 1.
3 by what?
Yeah, 3 by 1.
Oh yeah, sorry. It's 3 by 1. B is 3 by 1, not 1 by 3. Apologies. Yes, sir.
So does it have to be square brackets? Regular brackets?
Did you mean, okay, good question. Another question. Does it have to be square bracket or regular bracket? Both this bracket and this bracket are allowed, but this is not allowed. This means something else in matrices. We'll get there later, called determinants. You can write a matrix like this, or you can write like this. So I'm going to put that here. Good question, thank you. Okay? So AG, A, 1, 2, 3, 4, B, 1, 0, 3, 4, 9, 1. So we can write that. Okay? But don't use a vertical line. Vertical line is something else in matrices. So order. So this means the number of rows by number of columns. Okay, that's what we mean by order of matrix. So if a matrix, maybe X, I just assume X is the name of the matrix, it could be any letter. Okay? If a matrix X has m rows and n columns, it is of order what? Anybody? So of order what? Read that and tell me what to write.
X by N.
Okay?
No, N by N.
M by N, not M times N, please. M by N. So this is how we read it. M by N. That's how you read it. Of course, the product of those two, what do you mean? What do you think this represents? 2 times 3 is 6. What does it represent?
Number of elements.
The number of elements in the matrix. Because there's a question where I ask how many elements are in these matrices, right?
Yeah.
So if you can multiply the order, the rows and the columns, you can get how many elements are in the matrices. One question. What happens if m is equal to n? Do you know the name of such matrix? Give it a name. Square matrix. Yes, it exists. It exists because it's square matrices. So in that case, we don't say a matrix 3 by 3. That's a square matrix of order 3. Because it's square, we know it means 3 by 3. Does it make sense? You don't say you have a square of length 5 and width 5. Did you say that? What did you say? A square of side 5. We know the other side are automatically 5 as well. Do you get the idea now? So if m is the same as n, it is a square matrix. Okay, so maybe I write it here. What is that? If m is equal to n, you know what? I'm continuing from here now. Okay? If m is equal to n, then we have a square matrix. Have a square matrix. So AG. So a square matrix of order 2 will look like this. Y, 1, 2, 4, 7. Am I right? Because it's 2 by 2, right? A square matrix of order 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Can you see that? That's a square matrix of order 3. What do I mean by order 3? Anybody? 3 rows and 3 columns. So instead of saying a square matrix of 3 by 3, we just say a square matrix of order 3. Am I making sense, anybody?
Yeah.
Okay. So this is order 2. This is order 3. We don't need to say order 3 by 3. because the 3 and the 3 are the same. Do you understand that? So just a square matrix of order. So we have a square matrix of order n. Let me put it that way. Because m and n are the same. Just pick one. Giselle, lost?
No.
Confused? Understood? Right. Okay? Another terminology that I need you to know is something we call diagonal. Now, look at this now. This is a square. Everybody pay attention now. What are the elements in Y that are in the diagonal? 1, 7, 2, 5. So there are two diagonals, isn't it? You just picture it like a geometrical shape. Now look. This is a diagonal, this is a diagonal. Is that not?
Yeah.
Okay? But in matrices, we are only concerned with mostly with leading diagonal. What do I call it? Leading. Lead. Like taking a lead, kind of. Leading diagonal or a principal diagonal. And that is this diagonal. Okay? Do you understand? So the elements in the leading diagonal are 1 and 7. The elements here in the leading diagonal are what? 1, 5, and 9.
Does this only work in a square matrix?
Yes. Okay? We can talk about diagonals in non-square, right? But it's not going to be consistent. So you can have one here, one here. So we don't talk about it. So when we talk about leading diagonal, we refer to square matrices. Does it make sense?
Yeah.
Now there's something we can do with the leading diagonal which you don't need to worry about. There is something we call the trace of a matrix. The trace of a matrix is the addition of the element in the leading diagonal. So for example, the trace of this matrix is what? 8. And the trace of this matrix is what?
15.
But you don't need to worry about that. Nobody will ask you that in IGCSE. But of course, you get out of this place someday. You're going to be in maybe Form 5, Form 6. Then you talk about some of this stuff in more advanced concept. Then you get to engineering field in future from year 1 or year 2 economic student. Then you talk about this a lot. So I'm just like giving you an idea. But for now, you just need to know there's something called square matrix. How to add, multiply matrices. That's all you need to worry about for now. Understood? Okay. Now, there's a reason I mentioned the leading diagonal element. The reason I mentioned is because of special types of matrices we will learn later, not now. We call them the identity matrix and the diagonal, actually diagonal first. Diagonal matrix. When we have a diagonal matrix, every other element will be 0 except the one in the leading diagonal. So like this, 2, 0, 0, 3. This is a diagonal matrix. What it means is that the weight is only on the leading diagonal. In every other place is nothing. Does that make sense? So another one, 1, 0, 0, 0, 2, 0, 0, 0, 3. This is another diagonal matrix of order 3. Now, when does a diagonal matrix become an identity matrix? If these elements are ones. 1, 0, 0, 1. This is an identity matrix.
So same?
It's not the same.
No, the diagonals, the numbers on diagonal are the same.
What do you mean by that? This is another, hold on. Maybe I'm not getting your question right. This is another identity matrix.
Like, can it be 2, 0, 0, 2? Or can it only be 1? That's what he's asking.
What did I say is an identity now? Does anybody remember?
1.
I said if the diagonal entries are ones.
So only one.
So identity matrices are from here. But only those with ones in all their entries. Do you understand what I mean?
Yeah.
So anyone that has something like this, any matrix in the form of A, 0, 0, 0B, 0, 0, 0, C is what? A diagonal matrix. Anika? Any matrix that looks like this is a diagonal matrix. Now, if all these A, B, C are all ones, it becomes a special diagonal matrix called what? Identity matrix. It's not. 1 is an identity element, thank you. Because of the ones.
Oh.
Does anybody know why we call 1 identity element in operation? In multiplication? We call one identity element.
Because one times
Because one times anything remains the same. Look at it this way. It's an identity element because anything operates with one retains its identity. It doesn't change. 2 times 1. What do you get? 2. So this is, what exactly is the problem? This is one element in numbers that can let any other value retains its identity. What is A times 1? What do you get? A. So this guy allows this to retain his identity. That's why we call it an identity element in multiplication. In addition, what would be the identity element?
0.
That's it. Okay? So you can use the idea to remember this. So 1 is an identity element in multiplication. Okay? We have something we call a zero matrix. Who can guess what that means? If everything is 0. So it's not like a difficult concept as you think. Everything is about the grammar, the language, that's it.
Wait, but if everything is 0, doesn't that mean the whole thing is just 0?
That's what we are saying.
Oh.
It's a zero
Nobody-
matrix.
Then nobody writes that, right?
Well, we do because it has its usefulness
Like,
in mathematics.
How's it used?
like if you multiply,
Exactly.
If it
Well,
has
Okay,
the
okay,
same
okay.
order, it's exactly
How is it used? Yes.
how's it used?
What
Oh,
if,
wait.
what if the 0 becomes 1 in diagonal matrix?
Then it's no longer a zero matrix. If you have, listen, I'll go back to your question. If we have a 10 by 10 matrix, how many elements are there?
100.
100. And there's an element in a position that is 1, while the rest are 0, is no longer a zero matrix.
I mean, if it's diagonal matrix and then you turn all the 0 into 1 or other number.
You times all the 0 into 1, what do you mean?
You make the 0.
I turn all the zeros into 1, then it becomes like this.
No.
Is that what you mean?
No,
no, like that one, like the one,
the diagonal matrix, and you turn all the 0 into 1 or other number, will it be diagonal matrix?
No.
If I turn all the zeros into 1.
No,
Diagonal.
that's a regular.
Okay, if I have something like this, maybe like 0, 1, 1, is that what you mean?
Yeah.
No.
And then
And then 1,
1, 0.
1, 0. Is this what you mean?
Yeah, that's what you meant.
That's not what you mean.
Really?
Well, if you make
Can
it
you
0, that's what you mean. Can you know what you mean? Let's listen.
Let's say like
She's asking for
A.
He's asking the question, just listen. Okay.
What if, will it be diagonal
It's
matrix?
just a square matrix. Because you don't know what A is.
Diagonal.
It's just a square matrix. What makes it a diagonal matrix? Who can remember what I said?
Only the one on diagonal ones.
Only the one on diagonal are what? Are non-zero. Every other is 0.
But it looks beautiful for this.
That doesn't care about me.
She's looking at the beauty of it.
Yeah.
Really?
You can't find
Okay, but there is, look at this. Who can tell me, what do you think the name of this matrix will be?
Which one?
I'm about to write it. Unless you are inside my brain.
Rolling game.
Listen.
It says 0.
Larger than diagonal.
Right.
Oh my god.
Wait, larger or equal
Oh, I
to bigger
know.
diagonal matrix.
Stair matrix.
There.
Come on, think. Somebody already said something that is the answer. Triangular. What do you mean why?
They're very creative.
What do you mean why? It's obvious.
I think stair matrix. I think stair matrix. That was the
Wait. If you will call this a square matrix, you have a square shape. Isn't it a triangular shape?
Yeah.
Oh, that's a 0. It's like nothing there.
This still means the 0.
But wait, can somebody think of the terms to differentiate between the two? They are both triangular, right? How can we just about now? How can we differentiate between the two? There's a word you need to add. Something triangular, something triangular.
Inverse.
Not inverse.
Upside down.
Upside down. You're thinking. Flip, no.
Opposite.
It's just close.
Opposing.
No, 2 was
Spinning.
Up and down.
Ceiling.
Top
Up
bottom.
and upward. Up and
Close.
upward facing.
Face top.
Bottom. Base.
I'll give you an example. We did something called bounce.
What?
That's your clue.
Oh,
Upper and lower.
Oh.
So which one do you think is upper now?
The top one.
These are the first or
The
second?
first one.
Second, first one.
First one.
Why is the first one
Because
upper?
the first time is top.
Because the weight is at the top.
Oh.
So this is an upper triangular matrix, a lower triangular matrix. Do you understand? Yes, please. What?
What purpose do they serve?
Okay, one of the purposes is in question. Look, one of the purposes is in question. Okay, look at question 3. But you won't really appreciate the purpose here until we do multiplication.
Oh.
There's a question in the worksheet I'm about to give you multiplication, then I will be able to answer that question. I need you to say something first. Okay? And somebody was asking, why do we need a zero matrix? Of course we do. If you are trying to get addition of 2 matrices, okay, so maybe I have 2, 1, 3, 5. What am I going to do with, okay, look at you trying to solve the equation, maybe x plus 5 is equal to 0. Do we say what is the purpose of this 0 in this equation? You are trying to look for something to do to 5 in addition to make it nothing, right? If I have a collection here, what other matrix can I combine with it for everything to be nothing? Each of these entries might mean something. Look at your question 3. Let's read question 3 together. In one group, in 2010 Football World Cup, these teams all play 3 matches. Paraguay won 1, drew 2, and gained 5 points. The same, so you can look at the other countries. The question is, use this information in a 4x4 matrices. In a 4x4 matrix. Can somebody try?
Yeah.
Have you done it already?
Yeah.
Okay, give me the elements.
1, 2, 5.
1, 2, 5.
05. 0,
1, 2, 0, 5.
1, 1, 4.
So now, let's write this down.
Go
Can this go?
horizontally.
Okay, maybe I put it here. 1, 2, 0, 5, yes.
1, 1, 1, 4.
1, 1, 1, 4.
0, 3, 0, 3.
0, 3, 0, 3.
0, 2, 1, 0, 2.
3, 2.
0, 2, 1,
0, 2, 1, 2. Like that?
Yeah.
And this is a matrix. Somebody might have written it in a different form.
Oh, 1, 2.
Did anybody write it in a different form?
Yeah, you can write it.
So you can write it like this,
downward.
right?
Which one's right?
Both are right. That brings me to something else. 1, 2, 0, 5. Yes?
And then 1, 1, 1, 1,
1, 1, 1, 4. Yes?
0, 3,
0, 3, 0,
0,
3.
0, 2, 1, 2.
0, 2, 1, 2. There is a relationship between the. What do you think happens here to become that?
Oh, and also
Not flip.
the diagonal is still the same.
Of course, that's not.
Oh.
What happens to this to become that? That's my question. You rotate, is that the word? Use a bit different word.
Turn it.
You turn what?
No.
That's close.
Trans.
The name is start with trans.
Transformation.
Transform. Not the transformation yet.
Do we know what the word is?
What?
Is it a big word or do we know the word?
It's not a big word. It's not a big
We
word.
know it.
Okay, wait. So, okay, let's start with what happens here. What do you think happens here? Just give me in your own words what happens here to become that.
The word.
The horizontal.
Numbers get transferred to that other one. So transfer.
Of course, the number here, look at this row wise. What happens?
Like you.
I need everybody's attention on this. What?
The X and Y axis. Like
The X and Y axis, we don't call it X and Y axis. There's a word for it. We learned that today.
row and
The rows
and columns
columns. They switch. So they interchange.
They.
You said
It's
trash.
What's
Which
the
is same
word?
as switch, yes.
Wait,
So there's a
transfer.
row 1 becomes column 1. You
Oh,
interchange the
yeah.
rows and column. That's how we explain it.
What is the word? Transport?
Interchange.
No, what's the word of transport?
Hold on, I'm getting there. Interchange the rows and columns. You just calm down. Can you see what I'm saying here?
Yeah.
Row 1 here becomes what here?
Column.
Column 1. Row 2, column 2, and so on like that. So this and these are transpose to themselves.
Oh, I said it was
Did he say transpose? Sorry, I didn't hear that. Transpose. So if you find the transpose of this matrix, do you get the same matrix back?
Yes.
This one.
Oh, no.
It's different, right?
Yeah.
But some matrices are such that you get the same thing. Can you give me an example of a matrix that gives you the same transpose? Can anybody write something on the board?
A zero.
If you transpose and you still get the same thing.
A diagonal.
If you transpose and you must get the same thing.
That's right.
So like I said, this is the transpose of that, this is the transpose of this.
That makes sense.
Just make it a 2 by 2 to make it easier. And it's too big, come on.
Sorry.
Okay. That's an obvious one. Give us the one without that we have not all elements are the same. But this will give us the same, right? I need a matrix that is not all ones, different numbers, all true. Well, maybe not all true, but give me a number other than 1. Try.
Zero.
But a diagonal.
Wait.
1, 2, 2.
1, 2,
Oh, I know.
A diagonal matrix.
1, 2, 2, 1. Yes. Do you know what we call this?
Oh.
Is it a
What do you notice?
Does the diagonal go?
diagonal?
Double diagonal.
You're not listening. You are just, trying to say something. What do you notice here?
Slash.
The diagonal.
1, 2, 3, 3, 4, 5, 2, 4, 5, 3, 5, 6. Is this an example?
Is it?
So what do you notice?
Is it diagonal?
Think of a topic you have done before. You have learned somewhere in previous grade.
Symmetry.
Symmetry. So this is a symmetric matrix.
Oh, it's the same.
Oh, that's why.
That's why.
But that one's not.
Which one?
What?
Yeah. Why is it a symmetric matrix? Can somebody tell me?
The rows are the same. No, but it's not.
Oh,
Yeah, no, I'm saying it's not.
The fact that it's not,
It's
is
not
not
supposed
that is why it's not symmetry.
Oh. No, I thought you said. Oh, okay.
But if you are, wait, who's confused here?
No.
We're gonna move to the right thing now, to the main thing that we need. When is it a symmetric matrix?
1/3.
When
And when they
um,
colors and rows
it's
couldn't be switched,
symmetrical.
so they say the same.
You're not answering it like a math student now. When it is the same as the transpose.
Oh.
Oh, yeah,
This is the transpose of this. Are they the same?
No.
Now, if I get the transpose of this, will it be the same as this?
Yes.
Yeah.
That's why this is symmetric. If I find the transpose of this, will I get the same thing?
Yes.
Yes. If I find the transpose of this, will I get the same thing?
Yes.
Then this is symmetric. Yes. Okay, we have an African lady here. She's getting cold.
hide the.
African lady.
Oh.
Okay, does that make sense?
Yeah.
So the key word here is what? Transpose. So this is the transpose of this. This is also the transpose of this.
But they're not symmetric.
No, it's not. The fact that they are not equal is not a symmetric matrix. So if this is the original matrix, this is called the transpose. Okay? Does that make sense? Anyway, so let's go to the main thing that I need to point out here. Identity, diagonal. Did you take note of diagonal and identity?
No.
But you don't need that for IGCSE anyway. You can see it in the video later.
Oh.
You only need this basic stuff for IGCSE. It's just for your own
Yeah.
knowledge. Yeah, yes sir.
Do you call the transposed matrix a prime?
Prime.
Yeah.
What do you mean prime?
Like
No. Good question. It's asking for